Hello, welcome to 13 Universal Learning Beyond Borders. So this is A-level Caie Biology, and I'm Shedro, your biology tutor. So we'll continue in all topics series 6, follow our series. When we get to series 10 or series 8, we are going to go back to gas exchange, okay? So get your writing pad and pen and paper and calculator. Of course, come, let's go apply some concepts. Look at this. Number one, which statements about phospholipid molecules is correct? Phospholipid molecules. All right. So these are the options. Which one do you think is the answer? Let's analyze them. But you can pause the video and try to solve this question by yourself. Try it by yourself. Okay. Now let's go to the first one. They contain one saturated fatty acid and two unsaturated fatty acids. Okay, this is not correct. Okay, they don't always contain. We don't know, all right, the exact number of saturated fatty acid, all right, and that of unsaturated fatty acid. And again, we know that phospholipid molecules contain only two phospho, only two tails, right? Of course, is represented this way. Okay. Now we do not see the um, the glycerol. Okay, so you can see that it has two tails. All right. As a matter of fact, just to provide more context to this, because we're also learning. All right, this is triglyceride. You can see this is triglyceride having one glycerol and three fatty acids. You can see that. So this is phospholipid, that's triglyceride. So phospholipid is formed from triglyceride. So by replacing one of these fatty acid with phosphate head, all right. So it has only two tails, and from here it's telling us it has three tails: one saturated fatty acid tail, all right, and two unsaturated fatty acid. It has only two tails, all right. All right. So now A is wrong. B says they contain three phosphodiester bond. No, they contain two because they have two tails. So they have two ester bond. They don't even contain phosphodiester bond. Phosphodiester bond is found in nucleic acid. So what this has is ester bonds. So this doesn't apply. Phosphodiester bond is found in DNA and RNA, not in phospholipid. Okay. So this is wrong because we're looking for what is correct. What is correct? So C says they contain hydrophobic regions and hydrophilic regions. Yes. So this is the head. The phosphate group is hydrophilic, water loving. Why the tails are hydrophobic, water hating. So they move away from water. This move points towards or faces water. Hydrophilic head. So C is correct. But let's check D. They contain a hydrophobic phosphate group. Nope. Phosphate group is not hydrophobic. Hydrophobic means water hating. Phosphate group is hydrophilic, water loving. All right, it faces water and forms hydrogen bonds with water. So D is wrong. So the answer is, of course, C. They contain hydrophobic regions and hydrophilic regions too. So let's go to the next question. Hydrogen bonds explains many of the properties of water, including the high latent heat of vaporization and high specific heat capacity. For which processes in plant is hydrogen bonding in water important on hot sunny days? Hot is high temperature. Please note that. Okay. Now these are the statement: preventing the deterioration of enzymes in leaves, reducing water loss by evaporation, allowing leaves to cool down quickly at night, holding the column of water in xylem vessels together. Okay, so which one is the answer? Pause this video and check your knowledge out. Check your knowledge. This is where we apply knowledge. Okay, now let's go to it again. So hydrogen bonding explains many of the properties of water, including high latent heat of vaporization. So what is latent heat of vaporization? All right, it is the amount of energy required to convert water from liquid state to vapor, all right, to gaseous state. So it takes a lot of heat to do that, and because of the hydrogen bonds, a lot of energy is needed to break the hydrogen bond. Of course, let's look at high specific heat capacity. So define it for me. What is specific heat capacity? Specific heat capacity is the amount of energy required, all right, to increase the temperature of 1 kilogram of water or any substance, okay, by 1 degree Celsius. That means to increase the temperature of water, all right, by 1 degree Celsius, you need a lot of energy, all right. And this is why, of course, water plays a homeostatic role. Okay, so water responds sluggishly to change in temperature, increase in temperature, change in temperature. So water maintains relatively constant temperature in the body and aquatic environment. All right. So, but you see, the role of this actually is to, anytime there's evaporation, a lot of energy is removed. Okay. All right, let's see how it applies there. For which processes in plants is hydrogen bonding in water important on hot sunny day? This day is hot and then sunny. This with light intensity, this is with temperature. All right, so number one says preventing denaturation of enzymes in leaves. Preventing denaturation of enzymes in leaves. This applies there. Why? If you check latent heat of vaporization, okay? Now, in this day, the rate of transpiration will be high, remember? So, because of course, it will be high. But however, you know, because water has high specific heat capacity, it has high specific heat capacity. So, water requires a lot of energy, okay, to increase by 1 degree Celsius, okay? So it's going to take a lot of energy to get to a temperature that can denature this enzyme. All right. So water will slow down the increase in temperature. But most importantly, this latent heat evaporation, anytime water is converted, remember that during transpiration, what is going on there is that evaporation is taking place from the cell wall of mesophyll into the air spaces. Okay. So because of evaporation, a lot of heat is needed to convert water, because of latent heat evaporation, convert water from vapor from liquid to vapor. So anytime we have water converted from liquid to vapor, guys, you know what happens? A lot of heat is removed. So this helps to remove heat, excess heat from the leaf, and that prevents the denaturation of enzymes. Okay, one should be there. Now, reducing water loss by evaporation. Okay, reducing water loss by evaporation. Yes. So it reduces water loss by evaporation. How does it reduce water loss by evaporation? Now, because water has high specific heat capacity. All right. So high specific heat capacity, that means you need a lot of energy, okay, to break hydrogen bond, including this one. Both of them require a lot of energy to break hydrogen bonds between water molecules. So that reduces the amount of water evaporating. Okay. For water to evaporate, a lot of energy is needed to break hydrogen bonds between water molecules. All right. I don't want to do this, but just to throw more light, you know, on this. This is hydrogen. All right. This is water molecules. Okay. This is just a molecule of water. This is oxygen, hydrogen. Now, this is another water molecule there. This is the oxygen of that water molecule. This is hydrogen. Of course, you can see two water molecules. All right. Now, because of dipole effect, so hydrogen is positively charged, small positively charged, and oxygen is has a partially negative charge, a small charge there, because dipole effects, unequal distribution of charges. Oxygen being more electronegative draws, of course, the electron to each self. So now, because this is positively charged, so there's hydrogen bond formed between them. This is it. So a lot of heat is needed to break this hydrogen bond. Okay, so that's going to reduce the rate of evaporation. Okay, evaporation is movement from liquid to vapor. So the heat that is needed to convert to break this bond is high. So this is also an important process. This allowing leaves to cool down quickly at night. This has nothing to do with hydrogen bonds. Okay, though evaporation leads to coolness, but we're talking about hot sunny day. This has nothing to do, number one, this is in the night, this is dealing with the day, and again this happens due to radiation. Okay, infrared going back to the space, so 3 is not there. Now look at this, holding the column of water in xylem vessel together. Now, column of water is formed in xylem due to hydrogen bonding. Okay, so hydrogen bonding, that's cohesion between water molecules in xylem vessel, set up column of water. Now this is the wall of xylem. I'm just trying to show you something, guys. Stay with me. Right, so let's assume that the spherical shape is water molecules. So this is another water molecule. Okay, this is another water molecule. Right, this is another water molecule. I'm explaining so many things in this question. This is another water molecule. These are water molecules. Okay, so you see, water molecules are, they are able to form a column, this column, because of hydrogen bond. These lines between them is called hydrogen bond. That's cohesion. Right, so hydrogen bond helps to form water column. Right, yes, and also hydrogen bond between water molecule and the cellulose in the wall of xylem. Okay, cellulose forms hydrogen bond with water molecules, or the hydrophilic part of lignin. Now this is due to adhesion. The one I'm drawing by the side is due to adhesion. All right, that is adhesion. All right, hydrogen bond between water and the wall of xylem. That helps to maintain this water column. It helps to maintain water column. Right, helps to maintain water column. Right, so you see that hydrogen bond plays a role in number 4, both for setting up water column and also for maintaining water column. Cohesion sets up water column, adhesion sustains it, and of course transpiration pulls it up. All right, so 4 is there. 1, 2, and 4 should be the answer. So that's B. Let's go, guys. Which feature of cellulose molecules contributes to the function of plant cell walls? Okay, so these are the options. Pause the video and check it out. Let's see what you know. What do you know? Come on. All right. A says adjacent cellulose molecules are linked by glycosidic bond. Now, adjacent cellulose molecules are not linked by glycosidic bond in cellulose. What are linked by glycosidic bond is the alpha glucose, beta glucose molecules. All right, in a cellulose molecule. Okay, I join back. But for the adjacent cellulose molecules, they are linked by hydrogen bond. Okay, so not glycosidic bond. B says branch chains of beta glucose. Now this branch, cellulose don't form branch chain of beta glucose. It forms unbranched chain, so that's wrong. C says molecules of alpha. Now alpha glucose is not a monomer of cellulose, it's beta glucose, so that disqualifies it. So B, D looks like the answer. Unbranched chains, yeah, it's unbranched chains of beta glucose are linked by hydrogen bond. Yes, so unbranched chains of beta glucose. So if this is a chain of beta glucose, like a line, this is a chain, and this is another chain, and that's another chain. So they are linked together by hydrogen bonds. Okay, this hydrogen bond between the cellulose molecules gives them high tensile strength. All right, that high tensile strength is why they are able to provide support and strength to cell walls. Okay, so the answer is D. All right, let's go to number 4. Which statement describes some enzymes action? Enzymes hold reactive molecules so that their reactive groups are close together. Yes, it holds them together so that their reactive groups are close together. Please note this down. This is how enzyme functions. All right, we are also doing revision. 2 says in an enzyme catalyzed reaction, more molecules have sufficient energy to react than without the enzyme. Yes, this is correct, because enzymes, as a matter of fact, they lower activation energy. For example, if we needed 100 kilojoule per mole, okay, 100 kilojoule per mole of energy without the enzyme is a catalyst, so it lowers activation energy, kilojoule per mole. By the time you add enzyme would have lowered it like 20. All right, so you see, so more molecules will have 20. The molecules that will have 20 kilojoule definitely will be more than those that have 100 kilojoule, right? So if you lower it to 20, okay, remember, if you lower it to 20 kilojoule, all right, more molecules will have 20, so more molecules have sufficient energy. Remember the diagram, the energy pathway. Okay, you remember? Sorry for taking time to do this. So without the enzyme, you can see this is without it, right? Now with it, you can see the dotted line, it lowers it. it lowers it. So the second one, the dotted line, is with enzyme, so it lowers the activation energy, right? So without it, the activation energy is from here to here, but with enzyme, it's just from here to here. It lowers it. All right, so 2 is correct. 1 is correct. 2 is correct. Reaction catalyzed by enzymes take place at lower temperature. Yes, yes, take place at lower temperature. So if it lowers the energy, all right, energy is supplied in form of heat. Okay, heat. All right. So if at the temperature at 100 kilojoule is higher than 20. All right, so lower temperature, right, will be of course at lower temperature, take place at lower temperature because less energy is being supplied. All right, so 3 of them are correct. All right, 3 of them are correct. Let's go on. Influenza virus has an enzyme called neuraminidase, which breaks down glycoproteins in the surface membrane of the cell that the virus will infect. Glycoprotein binds to the active site of neuraminidase, okay, by induced fit. Which statement about the induced fit hypothesis of enzyme actions are correct? All right, induced fit, the active site must have the same shape as the substrate for them to bind. Pause this video. And then try to solve it. Okay, so try it by yourself. Try it. Pause it and try it. Okay, look at this. The active site must have the same shape as substrate. No, this is lock and key. 1 can never be in the answer. So you check here. A is eliminated. 2 says this enzyme is likely to be affected by non-competitive inhibitors than an enzyme working by lock and key. See, non-competitive inhibitors, they are inhibitors that bind to the allosteric site. They do not compete with the enzyme. They don't bind to the active site. They bind to allosteric site, and then when they bind, they alter the shape of the active site. Is that okay? So we have videos on enzymes. You can look at them, right, on 13 Universal YouTube. So if this is the enzyme, we took time to explain it, right? And this is the substrate, okay? Yes. So when non-competitive bind to it, right, something like this. When it binds to it, it has attached to it here. It changes it. It alters the active site. So this is non-competitive. So non-competitive binds to allosteric site. So you see it binding to allosteric site. Then the active site is altered. All right. So it does that whether for lock and key or induced fit. It's the same. So 2 is not in the option. So we know that answer should be 3. 3 says the substrate is converted to product by specific R groups in the active site, just like the lock and key. Yes. So there's this R group in the amino acid, okay, of the amino acid lining the active site of the enzymes. All right. So they form bonds, temporal bond with the substrate, and that creates ES complex. So the bond will either hydrolyze the substrate by mounting strain on it, or bring the 2 reactive groups together. So D is the only correct option here. So the graph compares the effect of temperature on the activity of the protease enzyme papain when in solution and when immobilized in arginate. All right. Which statement about the effect of immobilization of papain is correct? So what's the effect of? All right. So pause this video and try to solve it. Which one is correct? Which one is correct? Which one is correct? So pause the video. Which one is correct? Now, A says it alters the shape of papain active site at higher temperature. No, this is wrong. Remember that the activity of papain decreases faster in free. Okay, so that means that this is still most reactive, all right, at higher temperature. The one that is immobilized, this is, of course, the activity is low. At a high temperature, the activity is still high. All right, so it didn't alter the shape of papain's active site. All right, of course, we're dealing with the enzyme protease, okay, the activity of protease enzyme papain. So B says it decreases the activity of papain at high temperatures. No, it doesn't give it, immobilization does not give it disadvantage compared to the free enzyme. Can you see at higher temperature, the immobilized papain still has higher activity than the free, okay? So it increases stability of papain at higher temperature. This is correct. Remember that immobilization, of course, you know that the alginate, if it's immobilized by alginate, the alginate forms a protective coat around the enzymes and then prevent more hydrogen bonds from being broken due to high temperature. Okay, and then the enzyme now becomes more thermostable. All right, so immobilization makes enzyme, all right, more thermostable. All right, they are less likely, they're resistant, all right, to higher temperature because the alginate protects the enzyme. Okay, so C looks like the answer. This reduces number of collisions. No, it has nothing to do with number of collisions. Okay, with the substrate, in fact, it even increases it. That's why it has high activity. Okay, so C is advantage. So, all right, the diagram shows how adrenaline activates processes inside a cell. So adrenaline is acting as a cell signaling, all right, um, cell signaling chemical here binding to this. All right, let's see what it asks us to. They say which role is correct. Type of receptor. Receptor is either protein or glycoprotein. So it's not phospholipid. So the ones that have phospholipids do not act as receptors. So protein. We'll eliminate A and C. So we'll focus on B and D. All right, the next one says results of ligand binding to receptors. So when it binds to the receptor changes its shape. Okay, that's signaling transduction. All right, so B is the answer. Receptor does not leave memory, changes shape. That's how it works. Okay, B is the answer. The next one says the statement are comparison of endocytosis and exocytosis. Let's look at it. One, both are mechanisms that involve vesicles or vacuoles and transport of material across the cell surface membrane. They are both involved. Both mechanisms occur to allow bulk transport across the cell surface membrane. Yes, they involve in bulk. Endocytosis involves taking material into the cell, whereas exocytosis involves release of material from the cell. All right, the next one says some of the cell surface membrane is lost when endocytosis occurs, and there is an increase in the cell surface membrane when exocytosis occurs. Okay, all right, the question says how many statements are correct? So try. Okay, now this number, the first one, both mechanisms that involve vesicles, yes, both of them involve vesicles, if you remember. Okay, because if this is endocytosis, all right, is transporting this molecule. So the first thing that happens here is moving inside, right? So it folds around, right? The material that is being transported inside, that material is still inside here, and then vesicles are formed. Okay, yeah, to contain, so that material has been engulfed now. Okay, so vesicles is formed around it. Okay, and you see it's going to move across. It moves across the cytoplasm. All right, now if this is exocytosis, watch. Okay, remember for exocytosis, what happens is that of course vesicles carrying the material brought up from Golgi, and it moves across the cytoplasm. Okay, and then fuses with the cell membrane, adds to the cell membrane, and then releases the material, okay, to the external. All right, so you see that, guys, the first statement says they involve vesicles, yes, or vacuole. Yeah, this one forms vesicles, this one also forms vesicles, they both involve it. Two says both mechanisms occur to allow bulk transport across cell surface membrane. Yes, this is moving in a bulky material across the surface membrane. This is moving out bulky material out of the cell, okay, across cell surface membrane. 2 is correct. Endocytosis involves taking material into the cell. Yes, so you're moving material into, that's endocytosis. From endo, enter, outside to inside. Exo, it exit, inside to outside. So whereas exocytosis involves the release of material. Yeah, this number 3 is correct. 4 says some of the cell surface membrane is lost. Yeah, some of them here is lost in endocytosis. Can you see? Part of it is used to form vesicle, right? But in exocytosis, there's an increase. So this vesicle fuses with the cell membrane. All right, that increases the cell membrane. So all four of them are correct. Okay. All right, let's go to the next page. A student was asked to calculate the surface area of volume ratio for an algal cube. This is very important. Okay. Yes, with a side length of 5.5. Okay, so this cube is 5.5 millimeters. Which surface area to volume ratio is correct? So let's look at the one that is correct. So work this thing out, guys. Remember that in cube, guys, that we have this is, cube. Now they have the same length, the same width. Sorry, I didn't draw it very well, but cube has the same length, the same width. Okay. So if this is a cube, yeah, watch this. This is a cube. Yeah, so you see that the cube has, of course, same length, same width. And remember that we're doing surface area, okay, surface area, SA, to volume ratio. So this is volume, okay. So the volume of the cube, this is volume, sorry, volume of the cube is length times width. We're looking at total surface area. So this is the length times width, right? But we have 6 surfaces, right? So that means 6 times length times width. We have 6 surfaces, so surface area, right, all over the volume, which is length times width times height. Okay, yeah, so 6 surfaces. So that this will be 6, right, times 5.5. Okay, so I want you to bring your calculator. 5.5 times 5.5 times 5.5, right? All right, all over 5.5 cube, because it's the same thing. That's 5.5 times 5.5, right? Yeah, cube, that's times itself, because length, width, and height, they're all correct. They're all the same in a cube. Is that okay? All right, so they're all the same. They're all the same. So that is it. So by the time you finish, right, just use a calculator, punch it. So you see, guys, so if you multiply this times this times this, that's 6 times 5.5 times 5, this is 5.5, not 55. Let me correct it. That is 5.5, not 55. All right. Okay. All right. This is 5.5 cube. Okay. So if you multiply all of these, this is going to give you about 181. Okay. 0.5. All right. Yeah. So you divide it. If you find 5.5 cube, it will give you about 161, 166. So get your material, write it down, punch your calculator. 166.375. All right. So 375. So that should be 375. Okay. So when you divide it, it's going to give us 1.1. 1.01, that's 1.09, that's 1.1 is to 1. Okay, so the answer is D. So this is 1.1, this is 1. Okay, if you cancel this out with this, right? So that's the surface area. So D is the answer. Watch it again. Which statement about behavior of chromosomes during telophase is correct? Yes. So which one is the answer? Now guys, look at this. Chromosomes attach to the spindle fiber at equator. This is metaphase. This is behavior of metaphase. Chromosomes start to uncoil inside newly formed nucleus. This is telophase. So they uncoil in telophase. They coil up in prophase. Uncoil in telophase. C says chromosomes move towards the opposite poles. This is anaphase. Chromosomes condense. Prophase. D is prophase. C is anaphase. B is telophase, and A is metaphase, and we're looking for telophase. So the answer is B. Thank you guys for staying with us. All right, thank you. Please make sure you share this video, make comments, stay with us, and then like the videos, and then of course invite your friends. Okay, so see you at series 7. Bye.